Hey y'all, welcome back to my channel. My name is Jeffrey. Today I'm going to go over some pedigree as well as some general trends and analyses that you should be able to make. We have a man that's going to see a doctor and he's going to ask the doctor, look, I have a sister that has cystic fibrosis and I was wondering what were the chances of me being a carrier? Now, the doctor's answer to that question will be high. And the reason I know that is because we know that cystic fibrosis is an autosomal recessive disorder. Now, since this man is coming to the doctor's office and he's saying, what are the chances I'm going to be a carrier? We can reasonably assume that he does not have cystic fibrosis. He is not homozygous recessive, right? So because we are asking whether or not he is a carrier, we can assume that he is unaffected. And since his sister is affected, that means that at least one of his parents is a carrier for this allele. Okay? So I'm going to tell you right now, there's a rule, and it's called the rule of two-thirds. And the reason why I know that this patient or this individual has two-thirds of a chance of being a carrier for the cystic fibrosis allele is simple, right? So if we have the parents here and we draw out a Punnett square here, we can see that the chance of being homozygous recessive is going to be 1/4, right? But since we are looking to see whether or not this person is a carrier, we can eliminate that choice. So there's only 3 choices left. That's where the bottom number comes in. And to get the numerator, we have to see which of these, out of these 3 choices, which of these are going to be carriers. And that, of course, is going to be 2 of them, right? Because the last one is going to be homozygous dominant. So that's the rule of two-thirds. If you have a sister or a brother that's affected, you have a two-thirds chance of being a carrier for this allele. Now, if we were to ask, if this man were to ask, look, I was wondering what were the chances of my son being a carrier for this allele as well. And to that, you will then have to do some extra calculations, right? So you know that the man has a two-thirds chance of being a carrier, which is heterozygous, for the cystic fibrosis allele. The chance that his son or daughter is going to be a carrier is going to be 1/2. How do I know this? Well, to illustrate, I'll just draw another Punnett square, right? So let's just assume if he is a carrier, then he is going to have this genotype. And now his wife is likely going to be, either homozygous dominant or heterozygous for this. And we can see here that if she is homozygous dominant, there's a 50% chance that the child is going to be a carrier. Now, if she was heterozygous, we will draw the exact same Punnett square, but the fact that she's heterozygous. And if we do out the Punnett square again, we can see that there's still a 50% chance of being a carrier. So either way, however you want to draw it, there's a 50% chance that the son or daughter, in this case, is going to be a carrier. So what is the likelihood that the child is a carrier? It's going to be 2/3 times 1/2, and that's going to give you a 1/3 chance of being a carrier. Okay? So let's make this a little bit more complicated. We have a family here, and we're still doing the same thing. So the man comes in to the office, and he says, look, my nephew actually has cystic fibrosis. So what does that mean? That means his sister must be a carrier for this allele, right? And since his sister is a carrier for this allele, we're going to implement this new rule. It's called the rule of 1/2. Because she's a carrier, that means their parents must also, one of them at least, has to be a carrier. And if we were to go back to what we were looking at before, there's going to be that 1/2 of a chance, right? So that's where the rule of 1/2 comes from. So he has half a chance of being a carrier. Now, he is going to marry his wife, and his wife actually has a brother with cystic fibrosis. Now, thinking back, what rule is going to be implemented here? And if you guessed the rule of 2/3, you would be correct, right? So now you have a 1/2 chance of the man being a carrier and a 2/3 chance of his wife being a carrier. Now the question is going to ask, well, what are the odds that my son is going to be affected? What are the odds, right? Well, remember from that Punnett square, if we're assuming that both parents are going to be carriers, as we are saying here, the chance that he's going to be affected is going to be 1 out of 4, right? So there's a fourth of a chance that he's going to be affected if his parents are going to be carriers for this allele. So to find out the total probability that that son is going to be is going to be affected with cystic fibrosis, the odds are going to be 1/2 from the dad, 2/3 from the mother, times 1/4 of the chance of the son being affected if both of them are carriers. So when you calculate it all out, it's going to be 1/12 is going to be the odds that this son in this scenario is going to be diagnosed with cystic fibrosis or is going to have cystic fibrosis. Hope this video made sense. I hope that you guys found this helpful, and have a great day.